Okay, so this is the last part of section 1.4. So one of the reasons why we're talking about the limit is because we want to have a limit definition of the derivative. So just to remind you, the derivative is a thing that we use to find slope. So the slope of the line tangent to the graph x f of x is f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all over h. So remember, this is the difference quotient right here, which is what we were using to find slope a while ago. So the steps for using the limit definition is we're going to write the difference quotient, f of x plus h minus f of x all over h. We'll simplify it, and then we'll find the limit as h goes to 0. So for number 9, just diving right in, it says compute f prime of 4 for f of x equals negative x squared plus 2x minus 1. So this is what we're looking for. So we're going to use this little process down here, this whole process. So the function in question is this one right here. I'm supposed to find f of x plus h, which means for every x in this equation here, I'm going to replace it with x plus h. Okay, so I have negative x plus h. I always put like an excessive amount of parentheses because it helps. Plus 2x plus h minus 1. And then I will simplify that. Negative, so x plus h squared, I'm going to do x plus h times x plus h plus 2x plus, oops, forgot to put the x. 2x plus 2h minus 1. Multiplying that out, that is negative x squared plus hx plus hx plus h squared plus 2x plus 2h minus 1. Multiply that negative out. Negative x squared minus hx minus hx minus h squared plus 2x minus 2h minus 1. And then I can combine those two. Minus x squared minus 2hx minus h squared plus 2x minus 2h minus 1. Whew. So this part, that's tough. There's a bunch of little algebra things that people like struggle with. So if you have any questions on how I did any part of that, please ask because you're not alone. Okay, so I found f of x plus h. Now I'm going to plug it into the difference quotient. I know what f of x plus h is right here, so we'll start there. So this sucker equals, I'm going to write it below actually because we need space. I'm having trouble with the eraser. I want to erase. It's really struggling. Okay, guess I won't erase then. That is f of x plus h. We just calculated negative x squared minus 2hx minus h squared plus 2x minus 2h minus 1. And then I am subtracting f of x, which is minus x squared plus 2x minus 1. And then on the bottom, is just an h. So I need to simplify that, which I think will take a little bit. Let's see. Okay, I have a minus x squared here, and then I have a minus x squared. So a minus is a plus. So let's think of that. So if that's a plus, that's a plus. So I changed, this one becomes a negative, and that one becomes a positive. So minus x squared and plus x squared, these two cancel. And let's see what else is the same. Oh, there's a plus 2x here and a minus 2x here. So those ones will cancel. And then a minus 1 and a plus 1. So these will cancel also. That gets rid of quite a bit. It got rid of everything over here. All of that goes away. And I'm left with minus 2hx minus h squared minus 2h all over h. Which is great because there's an h in every single term. There's one here, one here, here, and one here. Which means I can cancel one out from each term. That gives me 2x minus h minus 2. Okay. So now I'm going to do the limit. Let's see, what was the limit? What does our limit definition say? Limit as h goes to 0. That's up at the top. So the limit as h goes to 0, 2x minus h minus 2. That is just a polynomial. So the limit as h goes to 0 of 2x minus h minus 2, I'm just going to plug it in. 2x minus 0 minus 2. That's just 2x minus 2. Oops, I plugged in the value right there. So, yeah, this is tough stuff, so we'll do one more example and then call it a day. Compute f prime of x for f of x equals 3x squared minus x plus 4. So the equation that we're starting with is this guy right here, 3x squared minus x plus 4. So I'll start by replacing every x in that equation with x plus h. I always use parentheses, that's really important. It's like important for getting the squares and the negatives right. It really helps if you do that. Okay, so at some point you're going to get really, really good at multiplying x plus h squared out. So we'll do that now, but eventually you'll have done it a ton and you'll basically have it memorized. So x plus h squared, that means multiply it by itself. Okay. So that is 3. So x times x is x squared plus hx plus hx plus h squared. Then I'm going to multiply this negative out, minus x minus h plus 4. So 3x squared plus 3hx. I'm multiplying the 3 through. 3 through plus 3hx plus 3h squared minus x minus h plus 4. Okay, in terms of simplifying, okay, it looks like I have a 3hx and a 3hx, so I can add those two together. 3x squared plus 6hx plus 3h squared minus h plus 4. Cool. Whew. Okay, first step done. I've got f of x plus h. Now I'm going to put it in my difference quotient. Okay, I have f of x plus h. That's what this guy is. So plug that in. 3x squared plus 6hx plus 3h squared minus x minus h plus 4. All of this we're going to subtract f of x now. F of x is the original equation, 3x squared minus x plus 4 all over h. Okay, so this minus over here, I'm going to turn that to a plus and make that a negative, this a positive, and that a negative. Okay, now I can do the adding straight through. So 3x squared and a negative 3x squared, those cancel. 6hx, 3h squared minus x. Okay, I have a minus x and a plus x, and then a plus 4 and a minus 4. So this whole second term completely went away. That is a good sign. That should happen every time. So now I'm left with 6hx plus 3h squared minus h all over h. Okay, there's an h in every term, so I can cancel, and I get a 6x plus 3h squared minus h plus 3h, and then it looks like minus 1. Okay, so the limit I'm trying to find, f prime of x equals the limit as h goes to 0 of 6x plus 3h minus 1. That's a polynomial, so I can just plug in the value of 0. So I get 6x plus 3 times 0 minus 1, or 6x minus 1. Okay, so let's pause here. Yeah, let's pause here. If you have any questions, let me know. This is a lot to take in. See you on the discussion board.